Welcome to Mathematics Made Easy with TADX, where mathematical concepts will be explained in clear terms for easy understanding. You can also join us on all our social media handles for more information.
Good day, pals. For today, we are going to be taking fractions involving binomial denominators. Just like I told us the last class that all the fractions we considered the last class, all of them were just monomial denominators. So today, we are going to be considering the binomial denominator. Now, when you say bi, that means you are talking about 2. So for today, if you look at this first question here, we have 5 minus x. 5 is the first variable while minus x is the second variable. So that means the two of them coming together gives you the bi that we are talking about. And apart from that, if you look at this one is just a single denominator, because when you have 4, the 4 is standing as 4 all over 1. So that means, as opposed to what we did in our last class where we had something like x all over 2 minus 3x all over 4 equals to 7. Now, when we add something like this was a single denominator, this was a single denominator here, because this is also all over 1. But in this case here, we're having two different variables for just only one denominator. So that's why we call it bi. Now, when we look at this second question here, we have y plus 2 at the denominator, here 2y minus 1 at the denominator. So 2y minus 1 bi, y plus 2 bi. So how do we now solve questions that is having binomial denominator? Very simple. Now what we just need to do is just for us to be able to bring out the LCM. Now LCM is different from when you have the monomial denominator. Like in this case here, when we are having 2 and 4 in this place here, what we just need to do is just use your normal tree method to get your LCM of 2 and 4, which will give us 4. But in this case here, when you are dealing with binomial denominators, consider the two values that are present in that question. Like in this question 1 here, I'm going to solve it in my rough book. Then after solving it in the rough book, we are going to transfer here. Now we have 2 divided by 5 minus x minus 4, everything equals to 0. Now here we are having the LCM here as 1 into bracket 5 minus 1. So that means this first one that is here, we use it to multiply whatever we have here. That means we are multiplying the two denominators here. The first denominator 5 minus x, the second denominator as 1. So that means the LCM I'm going to be considering here is 1 into bracket 5 minus x. Now, after getting your LCM, you now use this LCM to divide each of the value that you are having. Now, in this case here now, we have 1 into bracket 5 minus x. Now, divided by the LCM of the first one, which is 5 minus x. Now, when you divide this now, 5 minus x, you can easily cancel it out. When you cancel it out, this and this is gone, then you are left with just 1. So this one that you have here is what you are now going to use to multiply the numerator that is here. So when you multiply it by the numerator, then you are going to be having 1 into bracket 2. That means this one has cancelled this. It's gone completely. Now, the next thing is take the second one, which is 4. Now, we are multiplying the 4 by the LCM that we have here. The LCM here is 1 into bracket 5 minus x, which invariably is still the same thing as 5 minus x that we have here. So, if I multiply it by 5 minus x, then everything equals to the right-hand side here. What we have on the right-hand side here is 0. We are still multiplying it by the LCM that we have here. So the LCM we have here is 1 into bracket 5 minus x. And 1 into bracket 5 minus x is still the same thing as 5 minus x. So when you multiply it by 5 minus x, so that becomes 0 into bracket 5 minus x. So that means for this one here, we have to open the brackets. After opening the brackets for this, then you open the brackets for this as well. The same way we open the brackets for this first one that we are having here. So when I'm opening the brackets here, it's just like the way we multiply brackets when we're dealing with equations with brackets. In this case here, we're having minus 4 into bracket 5 minus x. If I'm extracting only this place here, that means I'll be having minus 4 into bracket 5 minus x. That means I've extracted only this place here just for me to solve. Now when I extract it, minus 4 multiplied by 5, that gives me minus 20. So I write out minus 20. Minus times minus here gives me plus. Then 4 times x gives me 4x. Now, after getting this expression here is only for this one in the middle. So I bring it here. So if I bring it here, that now becomes minus 20 plus 4x. Then that means I am done with the left hand side. This has been settled. This has also been settled. Now, coming to the right hand side now, just like the way I multiplied each of the values by the LCM. Now, I've written it out here. The 0 that we have here multiplied by the LCM, which is 5 minus x. So 0 multiplied by all these values here definitely give you 0. So everything we have here now equals to 0. So with this now, I can easily open this bracket that I have here. 1 into bracket 2 gives me 2. Then plus what I have here, minus 20 plus 4x, everything equals to 0. So this has now become a linear equation that we can easily solve down. So when you solve this down, the same procedure we started with then. Collect your like terms. After collecting the like terms, then divide both sides by the coefficients of x. So let's collect our like terms here now. So this becomes 4x equals to 0. This plus 2 crosses to become minus 2. Minus 20 crosses to become plus 20. So we have 4x equals to 0 minus 2 gives you minus 2. Minus 2 plus 20 gives you 18. Dividing both sides by 4. So this gives you x equals to, we can break it down gently. This is 2, this is 9. That gives you 9 all over 2. So x equals to 4 number 1 all over 2. So with that, the only thing I will advise you do is this. Whenever you want to multiply, take it one by one and evaluate it. If you're able to do that, you don't have any problem. Like I said, your SCM is very important. Now, let me transfer it. So let me write out the question. We have 2 divided by 5 minus x minus 4 equals to 0. So what I said initially was, guess the LCM. This 4 is not standing alone. It's standing as all over 1. 0 is also standing as all over 1. You are writing it there just for you to be able to see the brackets, the fraction that is there. Now, if this is 5 minus x and 1, when you bring it out, the LCM will be the multiplication of 5 minus x and 1. And then when we did it, we got 1 into bracket 5 minus x. When you multiply it, it's still the same thing as 5 minus x. So we now decided to multiply each value by this LCM that we have gotten. So we have 2 all over 5 minus x into bracket 5 minus x. Now, this one is what I wrote here. Now, take the second one now. Minus 4 all over 1 into bracket the LCM, which is 5 minus x. Now, equals to 0 all over 1 into bracket 5 minus x. Now, after doing that, you now start cancelling out. When you cancel out, it will be easy for you. This cancel this, you are left with 2. Now, in this case here, all over 1 is still the same thing as 4. So we have minus 4 into bracket 5 minus x equals to 0, because 0 will multiply everything there to give you 0. Now, from that, we can open the brackets that we're having in the middle here. When you open the brackets, you are going to be having 2 minus 20 plus 4x. Everything equals to 0. So when we got to this stage, I said we have gotten a linear equation. So what we just need to do is just for us to collect our like terms. When you are collecting the like terms, don't forget to put the algebra on the left hand side. All the numbers goes to the right hand side. That's 0 minus 2 plus 20. So with this we have 4x equals to 0 minus 2, that's minus 2 plus 20, 18. Dividing both sides by 4. X cancel out, the 4 cancel out 4. Then here, when we divided it initially, we got 4 whole number 1 all over 2. So that gives us the solution to the first question. And for the second one, we have y plus 2 equals to 5 all over 2y minus 1. Now let me rub off my rough book for me to be able to solve it again. So writing it in my rough book now, I'm having 3 into bracket y plus 2 equals to 5 all over 2y minus 1. I love this second question. and I'm going to use two different methods to solve it. Now, the first method I'm going to use is the method we used here. That's multiplying all through by the LCM. So that means the first thing we are going to do for us to solve this second question is we need to know what is the LCM in this case here. And for the second method I said I'm going to be using, the second method is just for me to cross multiply. When you cross multiply, everything becomes very easy for you. So let's see how we are going to do that. Now, when we start with the LCM, here we are dealing with two different values. The first value is y plus 2, while the second one is 2y minus 1. So just like what we did here, when I took 5x minus 1 and the denominator here, which is 1, I took the first one and the second one. Now, I'm going to take the 2 now. So taking this now, which is y plus 2 into brackets 2y minus 1. So that means the denominator here and the denominator here, I'm picking the two of them together as the LCM. So I will now use it to multiply each value. So multiplying the first value now, which is 3 all over y plus 2. Now let's multiply this and see what we are going to have. When you multiply this automatically cancel out this. When it is cancelling it out, you are left with 2y minus 1. So I write 2y minus 1. That is still inside brackets. Then I'm having my 3 here. Now, what we have here, if you want to do it, you can still twist it the other way around. The other way around in the sense that when you place this to come first, then this to be at the other side, that's still going to give you the same answer. That's when you have 3 divided by y plus 2 into brackets the LCM, which is y plus 2 into brackets 2y minus 1. Here, y plus 2 cancel out each other. You are left with 3 into brackets 2y minus 1. Now, the same thing we have here is what we are still having here. In mathematics, there's what we call the commutative law. What we are seeing here is the commutative law. Now, when you say commutativity, that's when the answer to the question does not differ, even when the arrangement is not the same. Take, for example, 2 plus 3, which is 5, is the same thing as 3 plus 2, which is also 5. So you don't say because 2 plus 3, the 2 is at the front, then 3 plus 2 will now be different. No, when the answers are the same, irrespective of the arrangements, then you are talking about the law of commutativity, and that is what is in play here. Now, taking the other right hand side now. For the right hand side, we have 5 all over 2y minus 1 into brackets y plus 2 and 2y minus 1. So what we just need to do here is this. The same way we have cancelled out what is common here. 2y minus 1, 2y minus 1. Because they are the same thing. Just like the way y plus 2 is here and y plus 2 is here, that I cancelled it out. After cancelling it, I was left with 2y minus 1 and I wrote the 3 outside. Now coming to this right hand side there, after cancelling the 2y minus 1, 2y minus 1, then I was left with 5 here. You write your 5 into brackets y plus 2. Just like after cancelling it, you have this, you have this. And you can still do it the other way around, the same way I've done it here. Now, here, I place the 5 all over 2y minus 1 first. Then the LCM at the other side. If I place the LCM first, which is y plus 2 into brackets 2y minus 1, before putting the value itself, which is 5 all over 2y minus 1. 2y minus 1 cancel out each other. Here you are left with y plus 2 into brackets 5. Your answer will still be the same thing. So you are still going to get the same answer. So what we just need to do from this stage is just for us to open the brackets. Now when you open the brackets, 2y times 3, that gives us 6y. Then minus 1 times 3 gives us minus 3. Then everything equals to, your right hand side now, we open the bracket as well, 5y plus 10. Then logically, when you have gotten to this particular stage, in short, it's possible for you to look at it and you get your answer even without solving. That means you are already doing mental drill. Now, in this case here, abstractly, you assume the 5y is crossing the other side. Now, when the 5y crosses, initially it was having plus here, which is invisible. Now, when it crosses, it becomes minus. So you have 6y minus 5y equals to the right hand side now, 10. The minus 3, which was on the left hand side, crossing to the right hand side, now becomes plus 3. So here now you are left with y equals to 13, which gives you your final answer. So I'm going to transfer it inside my notes now. So while transferring inside the notes, I'm going to use any of the method I've explained. That's either placing the LCM first before the value, or placing the number before the LCM. So here now I'm having y plus 2 into bracket 2y minus 1 into bracket now 3 all over y plus 2. Everything equals to 5 all over 2y minus 1. Let me cancel all this. So into bracket y plus 2, 2y minus 1. So look for what is common, what you can divide. We can divide this and this. So you are left with 2y minus 1 into bracket 3. Everything equals to, look for what we can divide here. We can divide this and this. You are left with 5 into bracket y plus 2. So when you open the brackets now, we have 6y minus 3 now equals to 5y plus 10. Collecting the like terms, 6y minus 5y equals to 10 plus 3y equals to 13. So we've gotten the answer correctly. Okay, let me now use the second method for the question. We have y plus 2 equals to 5 all over 2y minus 1. You know, when I started then, I said I'm going to use two methods to explain this question too. And the second method there is using the method of cross multiplication. Now, the symbol we use for cross multiplication is this. Though most of the time when you are writing, you just put this, and whoever is checking this understands that when you get to this place, you're already cross multiplying. What this symbol means is that you are using the 3 here to multiply this denominator, which is 2y minus 1. Then the 5 here, you're using to multiply y plus 2. And the reason why you're doing that is because you're having a single value at the denominator. That means just only one denominator is what you have on the left hand side, and you're also having one denominator on the right hand side. Let's look at this question 1 here. From question 1, you have 5 minus x. That's the first denominator. Then 1, which is the second denominator. Then here, y plus 2, just one denominator from your LHS. Then 2y minus 1, one denominator from the RHS. And that's why we are using the method of cross multiplication here. Here, we cannot use cross multiply here directly, just because we're having more than one denominator from the left hand side. Question 3, the denominator here, 2y minus 3. And we also have the second denominator here, which is 5. Since the denominator is more than 1 from the left hand side, then we cannot cross multiply. Even though you have more than one denominator on the right hand side, provided it's more than 1, you cannot cross multiply. So the only time you cross multiply in mathematics is when you have one denominator on the left hand side, then one denominator on the right hand side. Then you are free to multiply. And the denominator here does not really mean it's so compulsorily it needs to be a monomial denominator or binomial denominator. As at last week when we talked about the monomial denominator. So any of the value, then we can use it when it is just one on the left hand side, one on the right hand side, then you are free. So let's look at the way we are going to multiply this now. We have 3 into brackets 2y minus 1, then equals to 5 into bracket y plus 2. If you look at this step that we have here now, when you open it, you are going to be having 6y minus 3 equals to 5y plus 10. We should have something like this. Okay, this is it. Here we have 2y minus 1 into bracket 3. The same thing with what we have here. Then 5 into brackets y plus 2. 5 into brackets y plus 2. Now, when you cross multiply, the step is shorter. That means instead of you going through the stress of multiplying by the LCM here, you don't need this particular line which is long. You will just go straight. So here now we have, collect your like terms, 6y minus 5y equals to 10 plus 3. Here we have y equals to 13. Very short. So you don't need to waste your time. That's if you are dealing with questions that ask one denominator from both sides. So easily you'll be able to get your answer. So I'm going to leave this one here. I don't need it, since I've used one method to solve this one here. Let's go straight to the third question. For the third question here, we are having 4 divided by 2y minus 3, then minus 3 all over 5 equals to 0. Okay, to solve this third question now, what we just need to do is just for us to get the LCM. So the LCM here is going to be 2y minus 3 into brackets 5. So use the LCM to multiply each of the value that we have here. So that means we have 2y minus 3 into bracket 5. Then I'm going to use it to multiply what we have here, which is 4 divided by 2y minus 3. Now, the dot I used here stands for multiplication. So in most cases, if you see me using dots, it stands for multiply, multiply, multiply. So what we just need to do here is just for you to just cancel out what you have here, cancel out this, because 2y minus 3 is common here. It's easy for you to just multiply it. Then you're left with 5.4. That 5.4 is the same as 5 times 4. So 5 times 4 here gives me 20. Then I go to the other side. This is my minus. I bring the minus down. Then minus, what we have here is 3 all over 5. Then into brackets. Now that bracket, I may use it, or let me just stick to that's my dot instead of using the minus now. Dot, the LCM here, which is 2y minus 3 and also 5. So that's 2y minus 3 into bracket 5. Now I look out for what is common here. 5 and 5 is common from both sides here, so I can cancel out this 5 and also cancel out the 5, just like what I did here. 2y minus 3, I cancel out 2y minus 3. So here I cancel the 5 and 5 that is here. So what is left for me now is just for me to write this 3 into bracket 2y minus 3 that is left. So I write 3 into bracket 2y minus 3. Then I'm done with that. Equals to, now my right hand side here now, what I have on the right hand side here is 0. So I have 0. I'm also multiplying the 0 by the LCM, which is 2y minus 3 into bracket 5. Now whatever you multiply by 0 automatically gives you 0. So there's something I did here. What I wrote here, I'm supposed to have written it here so that I will not have to repeat that particular line. Let me bring it here. Equals to 0 into multiply 2y minus 3 bracket 5. Whatever you multiply by 0 here gives you 0. So I've written the 0. Instead of me repeating the line that is here, I don't need to write it here again. So what we just need to do is just for us to open the brackets. When you open the brackets, we have 20 minus 6y minus times minus here gives us plus. So we have plus 9 equals to 0. So when you have this now, what you just need to do is just for you to collect your like terms. So when you collect your like terms, we have minus 6y. Then this one crosses to the other side to become minus 20 minus 9. 0 is useless. I don't need it here. Now, if you now look at what we have here, you are just working with negativity. And mathematically, that does not really mean anything. That's minus 6y equals to minus 20 minus 9. That gives you minus 29. So dividing both sides by minus 6, minus 6. This and this is cancelled. So we have y equals to 29 all over 6. Now, when you have 29 over 6, you can either leave the question like this, or if you like, you can take it back to mixed fraction. Now, when you are taking this to mixed fraction, ask yourself, how many 6 will you see in 29? And it's easy for you to get that. Now, when you say how many 6 will you see in 29, that means y equals to 4. 6 times 4 gives you 24. Now, out of 29, when you remove 24, you are left with 5. That's 5 all over 6. That's when you break it down to mixed fraction. But logically, if you leave your answer here at 29 over 6, your answer is still very much correct. So that's the solution there. Now, the second method I said I'm going to use, I'm going to be a bit faster here now. When you have 4 all over 2y minus 3 all over 5 equals to 0. Now, from this question here now, the 0 that I have here was what I saw that made me to say I'm going to use 2 methods. Because 0 here is just to fill in the blank space so that it's not going to be as if there's nothing on the right hand side. When this minus 3 crosses to the other side, and the reason minus 3 over 5 is crossing is because from our previous classes, we've made it clear that numbers crosses to the right hand side, while the algebra stays. So the 2y here is the algebra, so it's staying on the LHS. So when it's staying on the LHS and this 3/5 crosses the other side, initially it was having minus here. So when it crosses, it becomes plus. So 0 plus 3/5 gives you 3/5. So this now becomes 4 all over 2y minus 3 equals to 3/5. Now, this is beautiful now because we're having just one denominator here and one denominator. Almost the same thing with what we have in question 2. Now, since it's the same thing with what we have in question 2, you can easily cross multiply now because we're having one denominator, one denominator. When you cross multiply, use this to multiply this, then this to multiply this. So now we are going to have 3 into brackets 2y minus 3 equals to 4.5. So when you open the brackets now, 3 into bracket 2y gives you 6y minus 9. 4.5 gives you 20. And mind you, when you're using 4.5, please try to be specific because of the target audience. If you are dealing with somebody in primary school and you say 4.5, or even somebody in JSS1, if you say 4.5, the person pronounces it as 4.5, and the person is not wrong because that's what the person is saying. So before you say it, try to explain to whoever you are explaining to that this dot is not just standing as points, but it's standing as dot product. So here you are multiplying it. When you collect your like terms, we have 6y equals to 20 plus 9. 6y equals to 29. The same thing with what we have here now. When you have 6y equals to 29 from this particular stage here. Now divide both sides by 6. Here this is gone. We have y equals to 4 whole number 5 all over 6. The same answer with what we got even when we use the first method. Now the bottom line is this: any method you like, you use, and that's the beauty of mathematics. Your answer is going to be correct. So to summarize what we've done so far, whenever you want to solve questions involving binomial denominator, what we just need to do is try to bring out the LCM. And to bring out the LCM, look at the denominator of the questions there. If it's 2, even though it's 3, multiply everything together, put it in brackets. Then use the LCM to multiply each of the value you have there. Then it will now be reduced to equation with brackets. Then after that, open the bracket. Then after opening the brackets, then you collect the like terms and you solve, you get your final answer. So I'm going to drop the exercise at the end of the video here. Solve it, and as usual, send it to my DM. God bless you till we meet again.